Okay, hello Year 7. Today we are going to go through how to create a simulation for your project, and you can see that I'm going into Tinkercad now and I'm creating a download or downloading a file of that Dragster model that you've made, and I've downloaded the STL file. I've then gone into a program or a website called airshaper.com and I've created an account using my Google School account. And you can see me now putting that file into AirShaper. You can't click on the dialog space where you can select a file. You've got to open up your Finder, go to Downloads, and drag that file into that space there that you can see. And then it's going to ask you a few questions. So you need to give your simulation a name. We're obviously doing an analysis to see how air moves around the shape, and then we're going to continue setting up this simulation. So in a moment I'm going to click next, and it's going to ask me for some more specific things. Okay. So now you can see I'm going to, on the left hand side, make sure that I'm setting up my simulation correctly. The car is racing on the ground. In this simulation we want it to be static, so the car won't be moving. We're just going to be seeing the air moving around the car. I'm setting up the speed that I want my car to be going, which is around 30 meters per second. Okay, and now if you have just set up your account, you'll be able to run one free simulation. Okay, so in this video you won't see me actually use my simulation or my file because I've already run a simulation, but when you click next, once your car or the model of your car is visible in this space on the screen, then you'll know the simulation is ready to be run, and you'll be able to move forward and actually create that simulation. So now it's starting to load into the website for you. So that's the model of the car that I've made on Tinkercad. I can now run that simulation. Because I can't use my car, I've just had to find an example car on the program, and this is a much more sophisticated Dragster that Year 10 students might do. And what it is showing here is the model of the car, but then also the areas of the car that, when the air is moving over them, are going to generate the most friction. Now, the two simulations that we are most interested in, I'll show you in a second, but it is not these first three that we're going through. They're useful, but they're a little bit more sophisticated to understand. But this vertical and horizontal interfaces are what we are interested in seeing. So you can see in those green lines how the air is moving over the car in the middle of it, and then you can also start pulling that airflow stream over different parts of the car to see how easily and cleanly the air moves over the car. So you can see here that all of the air moving over this car is green, and it is extremely straight. That would give an engineer an understanding that the car that they are producing is extremely aerodynamic. Okay, now what I'm going to try to do is find you, so you can see now an instance where we can see some streams of air shooting out from the sides of the car, not in that consistent flow, and that is a part of the car that is not so efficient. So you can see, I'm going to zoom in on this leading edge underneath the car that is pushing the air out really wide, and that would actually slow the car down. So if I'm an engineer and I see something like that, I'm going to try to maybe adjust the shape of that surface to make it more efficient. And when you're running this simulation, you should be looking for those things as well. And when you see them, that's going to mean, as a team or on your project, you are going to adjust and redesign some of those surfaces to make them more efficient. So you can see here's another example of when the air shape color gets purple, that also tells you that it's not a very efficient shape, and we should try to adjust those surfaces there.